Hello students! Welcome to today's lesson, where we will explore two fundamental concepts in mathematics, factors and prime numbers. Understanding these concepts is vital as they form the building blocks for many other mathematical areas, such as multiples, divisors, and even more advanced topics in number theory. The plan for today's lesson is as follows. First, we'll introduce the concept of factors. We will then discuss even and odd numbers before finally delving into prime numbers. Together, these concepts will help you understand the structure and nature of numbers more clearly. For example, imagine you need to split a group of 12 people into smaller groups. Knowing the factors, you would be able to determine that you can create groups of 1, 2, 3, 4, 6 or 12 people without leaving anyone out because these are the factors of 12. So let's dive in and start breaking down the world of numbers into its fundamental pieces. First, let's introduce the concept of factors. A factor of a number is any number that divides exactly into that number, leaving no remainder. For example, to find the factors of 6, we look at the numbers that divide 6 without leaving a remainder. The numbers 1, 2, 3, and 6 all divide into 6 exactly, so these are the factors of 6. Factors help us break down numbers into their building blocks, making it easier to work with them in various mathematical contexts. Next, let's discuss even and odd numbers. An even number is any number that 2 divides exactly into. For instance, 2, 4, 6, 8, and 10 are all even numbers because dividing any of them by 2 leaves no remainder. Conversely, an odd number is any number that 2 does not divide into evenly. Examples of odd numbers include 1, 3, 5, 7, and 9. Understanding whether a number is even or odd can help in various calculations and problem-solving scenarios. Lastly, we will delve into prime numbers. A prime number is a special type of number that has exactly 2 factors, 1 and itself. It can only be divided by 1 and itself without leaving a remainder. For example, the first 4 prime numbers are 2, 3, 5, and 7. These numbers have no other factors besides 1 and themselves. Note that 1 is not a prime number, since it only has 1 factor rather than 2. Prime numbers are the building blocks of all other numbers because any number can be expressed as a product of prime numbers, a concept known as prime factorization. We will expand on this in later lessons. Now that we have covered the main concepts, we will go through some examples to solidify your understanding. For example 1, we will be finding factors. Let's find all the factors of 12. Begin by identifying the smallest factor, which is always 1. So 1 is a factor of 12. Next, consider 2. Since 12 divided by 2 leaves no remainder, 2 is also a factor of 12. Continue with 3. When 12 is divided by 3, the result is 4 with no remainder. Thus, 3 and 4 are factors of 12. Since 5 does not divide 12 exactly, 12/5 gives a remainder of 2, 5 is not a factor. Finally, 6 divides 12 exactly, so 6 is a factor. Lastly, 12 itself is a factor because any number is a factor of itself. Therefore, the factors of 12 are 1, 2, 3, 4, 6, and 12. Notice that we don't need to check if the numbers between 7 and 11 are factors, as they are more than half of 12, and so are too large to be a factor. This can also be seen by the fact that all of the factors can be paired up as shown, where the numbers in the pairs multiply together to make 12. We don't need to check between 6 and 12 as there are no smaller numbers left to pair up. For example 2, we will identify even and odd numbers. Let's identify whether 15 and 28 are even or odd. To determine if 15 is even, check if it divides by 2 evenly. Since 15 divided by 2 leaves a remainder, 7.5, 15 is an odd number. For 28, divide by 2. Since 28 divided by 2 leaves no remainder, 28 is an even number. So 15 is odd and 28 is even. Lastly, for example 3, we will find prime numbers. Let's determine if 11 and 15 are prime numbers. For 11, check its divisors. The only numbers that divide 11 exactly are 1 and 11 itself, making it a prime number. For 15, check its divisors. Besides 1 and 15, 15 can also be divided by 3 and 5 without a remainder. Thus, 15 is not a prime number because it has divisors other than 1 and itself. So 11 is a prime number and 15 is not. In today's lesson, we explored the fundamental concepts of factors, even and odd numbers, and prime numbers. We defined a factor as any number that divides exactly into another number without leaving a remainder. We then discussed even numbers, which are divisible by 2 with no remainder, and odd numbers, which are not divisible by 2 without a remainder, highlighting examples of each. Next, we delved into prime numbers, which are unique because they can only be divided by 1 and themselves without leaving a remainder. We identified the first few prime numbers, such as 2, 3, 5, and 7, and alluded to their importance in number theory. Watch the rest of the GCSE Maths course at Sophos Education.